So far, when we wanted part of an array, we've asked for it by position, by asking for index number 5 or for the first 3 elements of an array. This video is about asking for data by a condition instead. Give me every value above 30, or give me every reading that's out of range. This is called masking, and it's one of the things that makes NumPy so good for working with data. To get there, we need a couple of building blocks first, Booleans and comparisons, and then we'll put them together into masks. Along the way, we'll also see another place Booleans show up, the if statement, which uses them to make decisions. Let's start with the simplest type in Python that we briefly looked at before, the Boolean. A Boolean has just 2 possible values, true and false. So we can see how a Boolean value looks when it's printed. So I'm going to create a variable called isRaining and then assign a value true to it. So there we have our Boolean, which is raining. And note the capital T. So when I was declaring it, I wrote true with a capital T, and it printed out is raining with a capital T. So Python is a little picky about that. True in lowercase will not work. Same with false. Whenever you're declaring a Boolean, you want to declare it with a capital T true or a capital F false. But we'll rarely type true or false by hand. Usually they'll come from comparing things, and that's what relational operators do. They compare 2 values and give you back a Boolean. So I'll start off with writing a few examples for relational operators, and then we can talk about what they're going to do. So there we have a few examples that you'll probably see very often. Double equal sign asks, are these equal? The exclamation equal sign, are these not equal? The greater than and the less than symbols are asking the same question. Are they greater than or less than the values? And then you can also have greater than or equal to values. In this case, 5 is not less than 2, so that gives you false, but 5 is greater than or equal to 5, and that gives you true. So each of these cases compares 2 values and hands back a true or false. And we can also see the types for these variables in the variable explorer. And there you can see check 1 to 4 are Booleans, and they have either true or false values. So one thing to be a little careful about, a single equal sign assigns a value to a variable. 2 equal sign compares 2 values. So an example for that is, let's assign a value 5, and this is a single equal to sign, so that will be 5 is assigned to x, and then we can do a comparison by saying is x equal to 5, and that is your double equal to, which is going to be a relational operator, and it gets assigned to the variable is 5. And so when we print it out, we'll get is x equal to 5, and then is 5 is a Boolean, and that gives you true. So they're both doing different things. The singular equal to assigns and the double equals checks. Often one comparison isn't enough. You want to check 2 things at once. Is this age over 18 and under 65? To combine conditions, we're going to use logical operators. To combine relational operators comparing scalars, the logical operators are words, and, or, and not. So we can see an example. I'm going to say age equals 25, and then I'll say in range. So the in range that we want to look at is age greater than 18 and age less than 65. Let's do another example. And then we can print it out. So let's look at what we've just written. I've declared a variable age that is 25, and the range that I'm looking at needs to be above 18 and below 64, and that's what this condition does. The AND is only true when both of these sides are true. You could also say OR, and in that case, it would be true when one of these sides are true. The next one is another variable called isSunny, and then the not operator that is in the bracket here turns our isSunny from false to true. So it is sunny. So that's how you can use the words to combine relational operators that are only dealing with scalars. What we'll most likely end up working on more is using arrays, and this is the important part. When you want to combine conditions across a whole array, element by element, you can't use these words. You're going to use symbols. So you'll end up using ampersand for and, a vertical bar for or, and a tilde for not. So let's look at an example for that. I have an array that's already been declared, which has values from 1 to 5. Let me combine some operators that are going to look at this entire array. And then we can print it out. Each of these are comparing the whole array at once and gives back an array of Booleans. So a greater than 1 and a less than 4 is only true when both the conditions hold. In our array, that would be true for 2 and 3, and that's what we get for both. Or is going to be true for either cases, so it has to be less than 2 or greater than 4, and that's true for either end, so 1 and 5. And the negated negates the conditions that are returned by this expression. So a greater than 3 is true for 4 and 5, and then negated, that will become false, and these will become true. So you end up with true, 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 and then false, false. So 2 things to get right here. First, when you're working with arrays, you need to use symbols and not the words and, or not. The word versions don't work element-wise on an array. They'll actually throw an error. The symbols are the element-wise array operation. Second, notice the parentheses around each comparison. That is not optional. Without parentheses, Python will evaluate the ampersand or the vertical bar before the comparisons. So the pattern to keep in mind is parenthesize each condition and then join them with and or cases. There are also functions that are called NP logical and NP logical or that do the same thing, but the symbols are cleaner and what you'll most likely use in practice. Another application of Boolean expressions is in if statements, where we use them to make decisions in code. We're going to see how we can use Boolean expressions with scalars to decide which block of code to run when a condition is true. I'm going to uncomment some code and then we can talk through what this example is. Let's read it from top to bottom. So our variable temperature has been assigned a value 22. If temperature is greater than 30, this case is not true with our temperature value since 22 is less than 30. So Python skips this block, this print statement. Then it goes to the next if, and in this case, it's an elif or else if. Is the temperature over 15? And that case is true. So then it'll print it's mild. And that's what we see in our output console. Once a branch matches, the rest of them are skipped. So else, the last case, never runs. You'll see this in 3 different ways. Just the if statement on its own for a single optional action. If with an else for a this or that choice. And if, elif, and else when there are 3 or more or several cases to sort through. You can have as many elif branches as you need. Each condition ends with a colon. Lines that belong to it are indented underneath. The indentation isn't just for visual clarity. It decides which lines belong to the if branch and which belong to the else or elif branches. So in this case, you could add another print statement or any other statement here, and as long as it's indented correctly, it would be part of the same if branch. The same goes for the other ones. Now let's get back to arrays. Boolean expressions can be used to filter data by creating a mask. A mask is just a Boolean array, which is a sequence of trues and falses marking which elements of the array to keep and which to discard. You make one exactly as we have been doing so far by comparing an array to something. So let's look at how to make that. So we'll create an array, or an array is already created here for me, and that's just goes from 0 to 4. And we can have a expression here that compares these two values. So y equals to x greater than equal to 3. And then we want to print y. So that prints out a Boolean array. That array of Booleans is called a mask. You can build a mask from a combined condition too using operators that we just learned. So we could have another variable z and then combine two conditions. So x greater than equal to 1 and x less than 4. And then print that out. So this one's true where the value is at least 1 and less than 4. The middle three positions. So a mask can be as specific as you need. On its own, a mask is just a list of trues and falses. The useful part is what you do with it next. Using a mask to pull out data is called masking, or we're going to filter an array. And this is where it gets genuinely useful. So we have an array over here, which has 5 cities: Miami, Denver, Boston, Phoenix, and Chicago. And their temperature in Fahrenheit lined up so the temperature matches the city in the same position. For instance, Miami is 85 degrees, Denver is 42, Boston is 49, and so on. Say we want the cities with temperature under 50 degrees Fahrenheit. First, let's build a mask from our temperature array. So we'll call it cold cities mask. And we'll say we want all of the values that are less than 50. And then we can print this mask. So that's the mask. True for the cities under 50 degrees. So that would be false, true, true, false, true. Now the cool part. We take this mask built from the temperature array and use it to index the cities array. So we can create another array called cold cities and use the mask array, the masking array that we just looked at, the cold cities mask. And get out just the cities that are cold. So Denver, Boston, and Chicago. Exactly the cities whose temperatures were under 50 degrees. We put the mask inside the square brackets, and NumPy kept only the elements where the mask was true. The mask came from the temperatures array, and then we used it on the cities array. As long as the two arrays are of same length, a mask built from one can filter the other. You can ask a question for one column of your data and use the answer to pull matching rows out of another. And that's the real power of masking. We can also use masking to assign values. So instead of just pulling out values, you can change them. You put the mask on the left-hand side of the assignment. So let's look at another example. We have an array of readings, and that has these values 12, 45, 8, 90, 33, and 5. So then we use masking to store specific values. Let's look at this middle line a little carefully. Readings with square brackets, readings greater than 40, selects only the elements over 40. And in this case, that is 45 and 90. And then we assign 40 to all of them at once. Everything else is left the same. So when we run the code, we end up with 12, 40, 8, 40, 33, and then 5. So any value above 40 is assigned 40. That's a one-line way to clip, clean, and replace a whole subset of your data based on a condition, and there's no loop required. A quick recap of what we looked at in this video. To do masking, we started off with the small pieces. A Boolean, which is a true or false value, and then relational operators, that includes double equals, not equals, the greater and less thans, to compare values and produce Booleans. For arrays, you combine conditions with symbols like the ampersand, the vertical bar, and each condition is placed in parentheses. A mask is a Boolean array marking which elements qualify, and masking uses that true or false value inside the square brackets, either to pull out a subset or to reassign one. A mask built from one array can be used to filter another array of the same size. So in the next video, we'll look at loops, which is running the same block of code over and over to achieve a repetitive task.